I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science in Jesus and Mary College, University of Delhi. So friends, I hope you all are doing well and you are pursuing the lectures which are being taken up by CEC in the various subjects. So in the domain of computer science, if you are following last two lectures actually we had focused on the topic of data mining. And if if we go through a quick recap of what we had done in the last few lectures. So we had discussed the introduction of data mining, the basics of data mining. Basically we were talking about what is this discipline of data mining, how interdisciplinary approach is used in data mining, and it is a amalgamation of various disciplines like the discipline of mathematics, statistics, machine learning, artificial intelligence. All these fields, they come together and we finally we get into the field of data mining. We had also talked about the various kinds of tasks which are adopted to mine the data, right. So we had talked about anomaly detection, we had talked about classification, association analysis and all these things. So now in today's lecture we will be talking about the data and the data sets and their types. It's very important to understand that what are we going to mine, right. So we are looking for some patterns in in huge amounts of data, right, and we are looking for some unknown information. We are trying to discover knowledge which is hidden in these databases. So this is knowledge discovery in the databases. So we are looking at the data, and when we are looking at the data, it's very important for us to understand how the data is organized, what are the attributes of the data, because ultimately whatever technique we are going to use is going to be dependent upon the structure of the data that we are getting, that we are using for mining. So we understand that the data can be of various types, right. So data sets, they can vary, right. So we have objects, right, for which we are storing the data, and these objects could be quantitative objects, these could be qualitative objects, and every object has a set of special characteristics. That is that data sets, they will have, some data sets will have time series data, or they will have some objects with explicit relationship with one another, right. So basically whatever is the type of data, whether it is quantitative data, it is qualitative data, that is going to help the data analyst understand and choose the correct technique for analysis. But before we start working on the data, the analysts start working on the data, it's very important that we have to see that the data is of a reasonable quality, right, because some level of imperfection in the data can be tolerated by most techniques, but at the end of it the quality of the results, the quality of the analysis will definitely be dependent upon the quality of the incumbent data, right. So therefore we understand that the data which is being given is far from perfect, it is not a perfect data, and therefore quality issues have to be addressed, right. So these, what are the quality issues that we may encounter, or the data analyst may encounter? It could be the presence of noise, or it could be the presence of outliers, or there are some missing values, there are inconsistent values, there is some inconsistent or there is some duplicate data, right. So basically the data is has to be cleaned, it has to be processed, and before it is actually used for the mining purposes, the data has to be made the best suitable, so that we get the best set of results after the analysis has been done. So these steps which are done, or this what we call this as is pre-processing, right. So we have to make the data, we have to clean the data to make it more suitable for data mining. So the raw data is pre-processed, it is it is cleaned, and then it is made of a reasonable quality so that it can fit the data mining technique or tool, right. For example, if we will talk about the types of attributes, but we have length, right? Now length is a continuous value. So length can be in decimals, you can have 10, 10.2, 10.3 like this. But for a specific technique, we may have to choose the value as discrete value. How? Say we will say that up to a certain level the length will be designated as short, then it will be medium, or then it will be long. So what we are saying, that we are categorizing, we are processing the data, we are sort of tweaking the data so that it can be used, a particular technique can be applied to that particular data set. Another example could be that sometimes we see that the data set has got too many attributes, right? It has got too many columns, okay? So now we have to go for reduction of this number of attributes, because certain techniques they work more effectively when we have relatively smaller number of attributes. So likewise there are several types of pre-processing which is done to the data to make it suitable for a particular technique, right? So what is done in this? The first step which is done is to analyze data in terms of its relationship, right? So we understand that the different objects about which the data is collected. So these different objects, they have some relationships among them, right? And these relationships have to be analyzed. So we are actually not just looking at the objects, but we are also looking at the relationships, or what we call as the association between the different objects about which data is being stored, right? So for example, if we want to calculate, we have two pairs of observations or we have two pairs of objects, right? So we want to use clustering or classification techniques, right? So what are we using? We are using the similarities or the differences between the values of these two objects, right? So we will look at the distance between the two values or two data objects that we are looking at. So particular techniques will require us to look at different kinds of relationships which are there in a particular type of data, right? So now we understand that the data is very important and the quality of data is very important before we choose the correct data mining technique, and we have to pre-process the data, we have to analyze the data, analyze the relationship among the different objects, data objects, before we actually choose a particular technique for data mining. Now we understand that what are the different types of data that one will have to deal with when you are talking about data analysis. So when we are looking at a data set, so what is a data set basically? It is a collection of data objects. So different objects, when we are putting together, they are known as data objects, right? So the data objects are known by different names. So we can call it as a record, we can call it as a point, a vector, event, case, sample, instance, observation, or entity, right? So all the real world objects, they can be understood, they can be looked at in the form of data objects. These could be tangible, these could be intangible, these could be qualitative, these could be quantitative. Now data objects, every object or every entity has a number of characteristics or a number of attributes. What are attributes? Attributes will capture the characteristic of an object, right? So characteristic or attribute, this is also known as by the name of feature. It can be called as a field, it can be called as a variable, or it can be called as a dimension. So for example, if we have an object, say we have a student object, right? So in this is a data set, okay, which is containing information about the student. So we can see here that in this data set we have got, at least we can see 3 different student object instances are there, 3 records are there, right? And student ID, year, and GPA or grade point average are the 3 characteristics which are defining three attributes which are defining the properties of the student object. So, you know, this is what we are trying to say, that we have a data set. A data set has got number of data objects, and for every object we see it in the form of a record, and every object has certain characteristics. Those characteristics are shown in the form of attributes or in the form of fields or in the form of columns if it is a tabular organization. So, what is an attribute? Attribute is actually a property or the characteristic of an object. An attribute can vary from one object to another and from one time to another. Like for example, the attributes of a student object will be student ID, year, you know, and GPA. The attributes of a teacher object will be teacher ID, teacher name, date of joining, etc. Right. So, the objects, different objects will have different attributes because their properties are different, and the same object can have different attributes from one time to the other, right. So, attributes are not about numbers or symbols. This is very important, that we are actually looking at the characteristic of the object, but we assign numbers or symbols to them so that, you know, it becomes well defined. It is easy for us to analyze the characteristics precisely, because if you do not assign a value to an attribute, if you do not assign a value to a property, then you cannot analyze that attribute precisely, right. So, because we are using mathematical models or we are using other analytical tools, so we need to have a well defined way in which, you know, the attributes are given a particular value. Now, that value could be a symbol or that value could be a number, right. So, for this, for assigning a value to an attribute, what we need is a measurement scale. So, measurement scale is very important because we are going to define the rule which is going to associate a value, whether numerical or symbolic, with an attribute of an object, right. So, we have a scale, we have a rule which will define that value. For example, if we are defining age, right, age is an attribute. So, age has to be defined on years. Age can be defined in days, age can be defined in months, age can be defined in, you know, decades also. So, there are different ways, you know, in which the value can be defined. So, the process of measurement is actually the application of a measurement scale to associate a value with a particular attribute of a specific object. So, we want to associate a value, so we have to define the value in the form of a measurement scale. We are applying a measurement scale so that a value can be given. It is common, you know, to refer to the type of an attribute as the type of the measurement scale. Type of the measurement scale means that we can say that an attribute is a numerical attribute, or it is an integer attribute, or it is a text based, or it's, you know, a symbolic attribute. So, attribute can be described using different measurement scales, and the properties of an attribute need not be the same as the properties of the value used to measure it. Now, this is very important. We have different attributes and we assign a value to an attribute. Now, the value which we are assigning to the attribute, say we are assigning an integer value. So, the properties of the integer may or may not be applicable to the property of the attribute, right. For example, we have two attributes, employee ID and age. Now, ID and age both are numbers actually. So, we define ID also as number, and age, which is in years, is actually also a number. Now, numbers, they have got certain properties, right. Numbers have got the properties that they can be added, subtracted, you know, divided, multiplied. All these properties are applicable to numbers. But if you look at employee ID, ID is a numeric field, but all these properties of numbers are not applicable to employee ID. What are we going to do with the employee ID? Maximum we are going to compare the two employee IDs, that whether they are similar or they are dissimilar, right. So what we are saying is that employee ID, although it is a number, but it is not showing the properties of numbers, whereas age is a number and age can be having certain properties of numbers, right. So the value used to represent an attribute can have properties that are not the properties of the attribute itself. So ID is not a thing which is going to be, you know, numerically calculated at any time. So that although that is the property of the value, but it is not the property of the attribute, and it can be vice versa also, right. So we have different types of attributes, you know, what we look at. So a useful and simple way to specify the type of an attribute is to identify the properties of numbers that correspond to underlying properties of the attribute. So we understand that, you know, numbers or numeric data, it has got certain properties, right. Now those properties can be applicable to the attribute or they may not be applicable to the attribute. So we will identify the attribute type based on what properties of numbers it is inheriting and what properties of numbers it is not inheriting, right. So we have, you know, the following operations, that is what all we can do with numbers, what are the operations or what are the properties of numbers. So we have distinctness, that is we want to check whether two numbers are equal or they are not equal. Then we can order the numbers, that is, you know, less than, greater than and all these. Then numbers can be added and subtracted, that is addition and subtraction, and we have multiplication and division. So these are the four properties of numbers which are there. Now we will be classifying the attribute based on the properties which are shown by them. Out of these four, what all properties are shown by that particular attribute, right. So what are the four types of attribute keeping in mind the properties of numbers? So we have nominal attributes, we have ordinal attributes, we have interval attributes, and we have ratio attributes. So attributes are of four types keeping in mind the properties of numbers which are being shown by these attributes: nominal, ordinal, interval and ratio. Now let us look at each of these types and understand that what is nominal attribute and why is it called so. So each attribute will possess all of the properties and operations of the attribute above it. That is, we are saying that nominal is the lowest level and ratio is the highest level. So an attribute which is of the type ratio will also show the operations of the type interval, of the type ordinal and of the type nominal, right. So any property or operation that is valid for nominal, ordinal and interval will also be valid for the ratio attribute. So we say that the definition of attribute type is actually cumulative, that is the lower level, you know, as you go down, the properties of the previous level are inherited by the attribute type. So this table, you know, it clearly shows the four types of attributes and the description is given along with the examples. So we see that the first type of attribute here is the nominal attribute. So what is a nominal attribute? In this, you know, the values of the attribute, they are only to be compared, right. That is like, for example, employee ID, right, or account number, right, or the color of eye or the gender. These can only be compared with each other. You can find out whether they are equal, you want to find out whether they are equal or they are not equal. Other than this, no other operation can be done on this. So they are only, you know, taking the property of comparison in the sense of being equal or being unequal, equal to or not equal to, right. So nominal means that they are only having different names, that is, you know, their values which are being given to them, they will provide only enough information to distinguish one object from the other. Only that much information is given by the value by which you can distinguish equal or unequal. The second type of attribute is the ordinal attribute. Now ordinal attributes, you know, these are those attributes where, you know, you will like to order the objects, like for example good, better, best, right, or you want to give some rating, or you know, you want to have some numbers, right, you want to arrange them in a particular order. So here the value of the attributes will provide enough information to order the objects, that is, you have only that much information by which you can order the objects in higher order or lower order. Like for example rank, you can calculate the rank, or you can, you know, calculate the hardness of minerals, like this. So these are only enough information is present for arranging the values or arranging the data objects in a particular order. Now nominal and ordinal attributes, they are understood, they are termed as qualitative attributes. Qualitative, why? Because no quantitative function can be applied to this type of attribute. You cannot, you know, apply a quantitative function to hardness of minerals or to grades of a student, right, or to street numbers, right, or to employee IDs. So these are qualitative attributes. The third attribute is the interval attribute. So for interval attributes, the differences between the two attributes, differences between the two objects become meaningful. Say for example the two dates, right, or the temperature, right. So these are becoming important here because you can perform addition and subtraction, you can add or you can subtract the value. So we can actually use a unit of the measurement scale to compare the values, not just comparison, but we can find out the difference or the distance between the two values, that what is the interval between the two values. Say for example, what is the interval between the temperature in Celsius and the temperature in Fahrenheit. So for this you will use a function which is having plus and minus in it. So these types of attributes, they are called as interval attribute, which will show the properties of addition and subtraction. And the last type of attribute are the ratio attribute. For ratio variables, these are used for finding out addition, multiplication and division. So you can find out the difference and you can also find out the ratio between the two objects, two data. For example, temperature in Kelvin. Okay, for you can find out the length versus breadth, you can find out the mass, you can find out the electrical current. So here what we are looking at is, we are looking at the geometric mean. We can calculate the, what are the operations? We can calculate the percentage, we can calculate the geometric mean, we can calculate the harmonic mean, right. For others, there are only limited operations you can calculate. So now interval and ratio, these two types of attributes, they are known as quantitative attributes because you can perform the operations of addition, subtraction and multiplication, division to this type of attributes, which are actually the properties of numbers, which are actually the properties of quantities. So therefore these are the four types of attributes that we will see: nominal, orbital, interval and ratio attributes. Now another very important thing to be seen here is that what are the transformations which will define these attribute levels. So we understand that nominal, ordinal are qualitative and interval, ratio are quantitative because they have numerical data, and now nominal, ordinal have got categorical data. Now what are the transformations that we can perform in nominal? In nominal we can have one-to-one mapping, that is a permutation of values. In ordinal we can have order preserving change, that is, you know, the value will be, the order will remain the same. In interval we can calculate a new value by applying a formula, like we are doing using, you know, when we are calculating temperature from Kelvin to Celsius, etc. And in ratio we can calculate the you know, we can convert or we can get the new value by multiplying the original value with a constant, like when we are converting the length from meters into feet or from kilometers to meters, like this, right. So, this type of, you know, changes can be done. So, we will be continuing our discussion on attribute transformations in the next lecture. Till then, keep watching CEC. Thank you.